Hello and welcome to my talk, or welcome to reInvent. Welcome to my reInvent talk. This is my first recorded reInvent talk. My name is Darko, and today let's talk about something very special. The old saying goes, measure twice, cut once. Yeah, that's it. So let's try to apply the same age-old tradition or age-old knowledge to something else. Let's actually test twice and deploy once. What does this mean? Let's talk about how can we actually properly test infrastructure as code or infrastructure delivery on AWS with various tools, frameworks, and some best practices along the way. So what are we going to be discussing up today? If this is something you came for, welcome. So let's talk about why infrastructure as code. Let's talk about testing CloudFormation. The CloudFormation is the OG infrastructure as code framework on AWS. And then finally, let's talk about even more, bigger, better testing with AWS CDK. And this is also where we get to do a lovely, lovely demo. OK, first question of the day. What is infrastructure as code? No, that's not the question I want to ask. Why infrastructure as code? Why is this important? Why are we doing this? Let's answer this. Why are you, the developer, the engineer, why are you doing this? Let's take a step back. In the olden days, infrastructure looked like this. Not just in general, not the physical infrastructure, but when you think about infrastructure, this is what it looked like. A bunch of servers, well, desktop PCs acting as servers in this case, that you had to deploy. You had to rack, stack, cable, set up an IP address, install the OS, configure it manually. That took some time. One of my previous jobs was basically a server provisioning administrator, which, I get 500 physical servers in Fairbanks, Alaska. You fire up your favorite remote administration utility written in Java, mount your ISO, and install the server 500 times. Not fun. Well, things have changed. We've started treating infrastructure as code, or approaching infrastructure deployment through coded means, or through application, through automation. So infrastructure as code basically came up in the, let's say, early 2000s, where the cloud started booming up. We got a lot of scalable, globally dispersed application with a lot of different elements. And then we needed this thing called infrastructure as code to help moving that, help, instead of clicking a whole bunch of times and, of course, making mistakes, why not deploy it all through some lovely, beautiful code? So when we think about infrastructure today, how should it look like in your head? Like this. This is what should be in your head when you think about infrastructure. Everything on AWS is an API call. Everything you do, even the clicks, are an API call. Then why click? Why not just use some lovely code to provision your entire infrastructure? Well, it will make things so much smoother, so much better for you. It will make your day much, much easier. So to answer the question, why infrastructure as code? Well, it makes things much more, reproducible. It makes things much more predictable. It's so easy to understand what you're going to deploy when you see it in code. Also, it gives you the ability to actually use the tools, frameworks, all the things you have in your environment to actually deploy and test that code. Isn't that cool? And also, deploying across multiple stacks, multiple accounts, multiple development environments can be tricky if you do it manually. If you ever had to deploy production to dev manually or copy it, you know what I'm talking about. So it's much, much easier to do it through code. Speaking of code, what else do we do with code? What is this important thing we need to do with code to make it that much more awesome? I mentioned we click, we make mistakes. That doesn't mean we don't make mistakes in code. So what do we do with code? We test it. Of course, we run our code through a plethora of tools and frameworks to actually test our code. Then why don't we do the same thing for our infrastructure as code? Exactly. We should use testing frameworks for it as well. And this is where the old saying comes, measure twice, cut once. You want to make sure that if you deploy something to production, if you deploy this infrastructure, it needs to be tested, it needs to be validated. We don't want that pesky, bad production code entering production. we want to make sure we stop it early on before it can cause problems. Okay, so now let's actually move on to some concrete things, some practical things. Let's talk about testing CloudFormation. What is CloudFormation, Darko, you may say? Well, CloudFormation is this framework. It's the OG framework on AWS. It's the thing that I've started with on AWS as a framework to provision your infrastructure through the means of code. It lets you define infrastructure in templates, these lovely text files. It can be written in YAML or JSON. You define resources, you define their configurations, and just let it go, right? So there are a lot of ways we can actually test CloudFormation before we let it go to production. But where does it all begin? Where does testing begin? I'll give you a second to think about where does testing begin. As any good developer, as any good engineer will tell you, it starts in your lovely, cozy, warm, and snuggly text editor. You need to have proper testing in place already here. Now, what text editor? Which is the best one? We're not going to discuss that, it's a Vim, but you need to have the abilities to actually test code or have the ability to have some initial tests of your code straight in your editor. You want to fail fast. So if you use something like VS Code, there's a bunch of plugins for CloudFormation. For example, the CloudFormation NAG plugin that will actually lint and check your CloudFormation code within your VS Code as you're typing it to point to potential insecure patterns. Like in this case, hey Darko, you're creating an IAM role that has a asterisk action to its trust policy. That's a no-no. It's not a failure, but it's something you should think about before pushing it to production. And of course, this is just a plugin for VS Code. And the plugin is actually based off a lovely tool from the lovely folks at Stelligent called CFN-NAG. CFN-NAG is just a Ruby gem that you can set up locally on your workstation. It works on a command line. It works in your text editor, where you can just detect potential patterns for insecure infrastructure. The example I gave you with a very open IAM role. It can also enable you to bring your own specific rules. You can test it against multiple templates and a bunch of other things. It will give you warnings and failures if your template is potentially insecure. To get it, it's a Ruby gem, gem install cfn_nag -- user, and you can go off. The next tool, this is the more common one, and this is a great thing for anybody who started writing CloudFormation templates from scratch. It's called CFN-lint, or CloudFormation linter. This is just a linter. It's a static linting or syntax checking tool, but it doesn't just check the syntax. It actually checks your code against the CloudFormation spec. So there's a whole bunch of things. It understands what you're trying to run. And for example, in this complete example here, I'm actually running some EC2 instance autoscaling group. It doesn't matter, and it's testing the template. It's actually linting the template against two different regions, against EU West 1 and EU North 1. Why? Well, because EU North 1 doesn't support T2 instances, and the same template will work in Dublin, but it will not work in Stockholm. So CFN-lint is actually aware of this of the capabilities of a specific region while it's doing its testing. So pretty cool, pretty awesome. Now, static testing are fine. That's pretty cool. It's very useful. It gives you the ability to fail fast. But when it comes to CloudFormation, the ability to fail in a proper way, actually to test all the things, is you need to actually deploy things. Because even if CFN-lint says, yeah, it's fine, the deployment actually may fail. So to properly test it, you actually need to deploy the stack. And how to do it? Well, there's a lovely tool built by the folks from AWS Quick Starts called TaskCat. TaskCat is a testing framework or a tool for CloudFormation to test the CloudFormation templates by actually deploying them. So you create these tests with multiple different parameters, your regions, parameter sets, tags, all the you can set up some deny lists for specific AZs, and you point it to a template and say, hey, please launch these templates, please provision these templates somewhere, and let me know if this succeeds. So what TaskCat actually does is launches a template, sees if it's successfully launched, and if it is, it just terminates it. So you get the ability to actually continuously keep on testing your CloudFormation code as you go along. And this is important, especially if you have a massive library of CloudFormation templates. Imagine your service catalog templates. You want to be able to test these things constantly. So you will constantly keep running these tests through Taskcat every day, every week, every once in a while, because do you know when you do not want your CloudFormation template to fail? When you want to deploy it. So better let it fail somewhere earlier in the week than on a deploy Friday. So, okay, so these things are the part of CloudFormation. There's a lot of other tools. These are just some of them I mentioned. This is not the ultimate list of CloudFormation testing frameworks. We have only so much time. But let's move on to CloudFormation's sibling, cousin, a good friend of CloudFormation. Let's talk about testing AWS Cloud Development Kit, or CDK. How can we actually test our CDK infrastructure code in a proper way? So, first of all, why CDK? I need to mention CloudFormation once again. CloudFormation is this lovely declarative way of defining your infrastructure. You do things in JSON or YAML. It's great. It's very readable. It gives you the ability to strictly, specifically define what you wish to launch, right, in these two languages. But let's say you're a wizard in Python. You have this extensive knowledge of the Python language. You have this extensive team that has extensive knowledge in Python languages. You have tools, you have frameworks, you have pipelines, you have all of this in-house knowledge in Python. Why not deploy infrastructure as code via Python? Well, you can do that. You can shorten this learning curve of deploying infrastructure with CDK. So CDK actually, in essence, converts your CDK code, which can be written in Java, JavaScript, TypeScript, Python, and C#, and converts it to CloudFormation. You can use a very imperative way of doing things. You can use all the best practices of a general purpose programming languages, such as loops, reading off disks, and a whole bunch of other things you wish to implement. And it will actually provide you with some CloudFormation code. You can plug these things into your existing pipelines, in your existing workflows, into your existing toolings. And again, there's this amazing, vibrant community. Hello to all the CDK community members out there that keep on creating constructs and libraries and all these things to make your life so much easier when deploying infrastructure as code through CDK. But CDK is also code. And CDK is, dare I say it, more complex code than CloudFormation. What do we have with more complex code? We have more options, absolutely. We have more shortcuts. But we can also have more problems. So what do we do with that? We test it. We test our our Cloud Development Kit code. And the way we can do it, and especially when we're using something like JavaScript or TypeScript, we can actually use the Jest framework for testing our CDK code. Now, there's 3 types of testing, unit testing, we can do with CDK. We can do snapshot tests with Jest. We can do fine-grained assertions. And because it's a generic programming language, we can actually use the built-in, well, the already present validation tests as any other programming language can have. So let's talk snapshots. Snapshots are just a super simple way to have a really quick test. Think of it as taking a snapshot in time of your environment, of your infrastructure as code setup, and any changes that happen after the fact will fail because it's not matching your snapshot. So here's an example. Here's how a snapshot test looks like. I just say, hey, I expect my test, once it synthesizes, to match my snapshot. And then I run my test. I run npm test. If there's no snapshot present, if basically this has never been run before, it will create the snapshot out of the current setup. It will take your current CDK code, synthesize it into CloudFormation, and then create a snapshot. And the snapshot actually looks similar to CloudFormation. It's a bit different, but you can get the little vibes of CloudFormation in this code. So that's pretty cool. And then if I go ahead and change something, I keep on adding something and keep modifying it in the way it doesn't match my snapshot, I run a test again, and would you look at that? It fails my snapshot test. Of course, this potentially is pretty useless. If you're gonna just create a snapshot once in time and that's it, then why are you making changes? Actually, you have the ability to use the npm test -u command to actually update the current snapshot with the existing setup. So you can keep on updating. So think of this as being part of your pipeline where you have a firm snapshot that you must adhere to, and nothing else can go, right? You will have a separate thing that will create those snapshots in due time. But I want to have more fine-grained control. I don't want a snapshot. Snapshots are great, but there's better ways of doing that. I want to apply all the best practices of test-driven development to my infrastructure as code. I want to define things I want to expect. I want to set expectations to my code. So I can do this. There's also fine-grained assertions. I can set up a test that say, hey, I expect my stack to have an alarm, a CloudWatch alarm with this metric, with this namespace, and this dimension. Or I can say, hey, I want my stack to have an SQS queue with this message retention period value. So I want my stack to have these things. It can have other things as well, absolutely, but these things must exist and must be configured in this way. Then, if I create my stack with, let's say, the wrong retention period, it will fail. I run my npm test, and it just say, hey, this thing actually does not have this SQS queue with this message retention period set up. And please fix that. Of course, there's no snapshot. Basically, this is just a, hey, let me create this test first. Let me define this test first, and then make my code work good enough to pass this test. Typical test-driven development. Okay, so recap. CDK, the way we can do it. Snapshot tests, we can do fine-grained assertions, and also we can do validation tests. Now, I haven't talked about validation tests here. Validation tests are just a generic programming way of defining things. You create a little conditional within your code that, for example, the message retention period must be between these two values, and if somebody changes it down the line, it will fail. But again, not a framework-specific thing. But I did mention pipelines somewhere down the line, right? Pipelines are also very important, right? Because why? Well, treating infrastructure code as any other code is very important, right? So we need to actually move our infrastructure code down a pipeline. So let's say we commit our code to a Git repository. That thing gets picked up to a pipeline, goes to the build phase, or basically the initial unit test, linting, and packaging phase. This is where we run our CloudFormation lints and nags, and we run, for example, our Jest framework for CDK. And also, then we actually deploy it somewhere. We deploy it to a bunch of pre-production environments, and then we use something like Lambda functions to validate, hey, is this running? And if it is, oh, perfect, it's running. Please continue. And then finally, goes off to production. So when it comes to CloudFormation, this is how a fully fleshed out CloudFormation CI/CD pipeline would look like. We have our code commits, we have our code pipelines, we have our code builds, we have our task cats that are going to deploy our code to a pre-production environment, and then finally, if it is good, it's going to make the change set and actually deploy or promote those changes, successful changes, to our staging and production environments, right? So this is how it would look for CloudFormation. But let's see how this would look like on some CDK. And CDK has this lovely thing called CDK pipelines that does this job so good. So let's actually have a look at this demo, how CDK pipelines helps us create multi-account, multi-region, multi-stage testing pipelines for our application and infrastructure code as well. So let's have a look. So what you're going to see right here now is a directory where I have created my CDK pipelines application. It is actually consisting of 3 different stacks. Once we go to the lib directory here, we will see that we have our standard stack, the application stack, we have our Lambda function, we have our stage stack, and we have our pipeline stack. I'll go through each of these to kind of explain what they are and why they are important. So first thing we're going to have a look at is the actual stack, the application, our hello world of this demo. So going to lib directory and going to it's going to be the CDK pipelines -stack TypeScript file, and you will see here it's just a simple Lambda function and an API gateway. It's just a saying, hello, hey, this is just a Node.js Lambda function. We have a simple API gateway, nothing special, nothing out of the ordinary. If we look at the Lambda function, it just says hello from a Lambda function. Simple as that. Now, what are we going to look at right now is the stage. The stage stack is actually a wrapper stack against that application stack. So it will take that application stack, create a service that we can much more easily reuse that stack in multiple stages, multiple accounts, multiple regions. So it just makes things much more easier, much more compact. This is not necessary, but it makes it much, much more clearer. So cool. This will actually take this web service and deploy it across multiple things with the pipeline stack. Now, this is the meat and potatoes of all the things. This is where we actually use the CDK pipelines module on line 4 here. And this is where we define the things such as the pipeline. This is where we define our CI/CD pipeline. It's actually using AWS Code Pipeline. And we define like our source action, which is going to be in GitHub. So I'm going to be hosting my code on GitHub here. I need to define like an OAuth token so it can access it. I already did this in Secrets Manager, created this OAuth token, so it pulls this token out there, and it points to my CDK pipelines repository. Now we create a synth action. This is the build step. This is where we're actually going to be compiling our Lambda from TypeScript to JavaScript. So it's run just npm run build. And then last but not least, the actual stages, the pre-prod stage. This is where we are going to deploy in this specific account, in this specific region. Hey, deploy my CDK pipeline stage. Remember the stage stack? Deploy it within this account, within this region. Right, so US East 1 in this case, and deploy it to account ID, whatever, right? But also, we're adding a testing phase here. We're actually adding a test action, shell script action, to test if our deployment to pre-prod is successful. So what it's going to be doing here is going to be getting that endpoint URL, the API endpoint, API gateway URL. It's going to take it as just a variable. And code build is here actually going to run curl against it. It's just going to run a simple curl command saying, hey, does this work? And if it works, it says success. Please go further. And what is further? Well, it's the prod stage. It's going to create another stage in our pipeline called prod. It's actually going to deploy our code to a production environment. Actually, it's going to deploy it to a production account, which is a separate account in this case. Again, another stage called prod, right? And it's going to be deploying it to an account in, well, a different account. I'm not sure if you can see it. Those are different accounts. And it's also going to be deploying in the same region, but we can also do the same, different things. We can actually create an additional production account like this. Just copy, paste this. Hey, let's call it prod 2. Give it we're going to use the same account. Let's do a different region. Let's do EU West 1, move it to Europe. Call it that, and just give it a different name, called it EU prod. So this will, in essence, if I do this, deploy this right now, well, bam, we have multiple, and another stage to our pipeline. We can add as many stages as it is supported on Code Pipeline here. So, pretty cool. But let's not make those changes right now. Let's see how this will actually be deployed. We actually go to the deploy phase. And the deploy phase here is just, we need to, number one, you need to bootstrap your accounts here. Now, I've done this before, but you want to make sure that your accounts, all of your accounts that are being deployed to, are bootstrapped. Now, this has been done before, and you will be able to find this thing in the links later on. But you're going to deploy here. As you can see here, I'm actually running the CDK deploy command against the specific account. The profile is actually using my main CDK account, the one which I have the pipeline in, and it is actually going to deploy the CDK pipelines pipeline stack. So it's the stack that actually deploys the pipeline. It's actually this stack here right now. If you look at the binary file here, the bin file, it's basically the CDK pipelines pipeline stack. So it will just deploy the pipeline. It will not deploy the application itself. This command does not deploy the application. The pipeline deploys the application. Now, once this is done, no other changes should be done through the npm command, the CDK command. Every other change from then on should be done through good old Git. So deploy it once, and then just keep on pushing all of the changes just through Git commits. Now, I'm just doing a quasi-Git commit here. There's no changes here. I'm going to do a Git push. Again, nothing. But if there was something here, it would push the change. The pipeline, which we will see in a moment, would pick up the change and then move that change down the pipeline. So as you can see, this is the pipeline. This is our source phase. This is the GitHub phase. This is where we would pick up all the changes in GitHub. It uses webhooks for that. The build phase, this is where we synthesize our Lambda functions to JavaScript from TypeScript. This is where the npm run build happens. Again, this is dependent on your setup, but this is the big thing: the self-mutate, the pipeline that can actually update itself. If we add more stages to our pipeline, the self-mutate phase will actually keep on adding new things to the pipeline itself. So pretty cool. Because this is using a multi-account approach, we have the assets stage where we actually move our assets to an S3 bucket, and those assets can be much more easily distributed. And then we get to the pre-prod phase. This is where we actually deploy to pre-prod. We create the CloudFormation template. We actually prepare this CloudFormation change set. We deploy the CloudFormation change set here, right, by just running the deploy command. And finally, we test the service. This is that curl command. If we look here at the details, you will see that this has actually executed against the specific URL, the endpoint URL. We got the hello from a Lambda function, so it is a success, and saying, hey, it's a success. Please continue deploying to production. And finally, you can see here the pipeline is doing the same thing for production, preparing the change set and actually deploying the change set to production. Pretty cool. We were able to test all of these things going through multi-account, multi-region, and multiple different things. So how does this work? You create your things in your, you create all these stacks inside of your CDK pipelines. You deploy it once, and then from then on, you just keep on doing it through Git. And if you want to have a look at this code that creates this lovely pipeline here, you can actually check out that code on my Git repository, which is available here. It's a public Git repo, so you should be able to see it. Again, it's a very simple application, but hey, you may want to see it later on. With that being said, let's actually move on to the wrap-up phase, the best phase of this talk, to kind of give you some homework. All right, do this. Spice up your toolkit. Spice up your infrastructure code development toolkit, your IDEs, your workstations, your CLIs, with tools and frameworks to help you write, debug, and absolutely test your infrastructure code. You want to be able to fail really fast. Try to make your next infrastructure changes through a CI/CD pipeline. It can be code pipeline, it can be GitLab Actions, it can be whatever. Try to make it through a CI/CD pipeline. You will thank me in the long run. And finally, have fun writing good and secure infrastructure code, because you don't want to have this situation where you deploy a code and then it fails in production, and then you start yelling at the cloud, old man yelling at the cloud, oh, this doesn't work, I lost just an hour on waiting. Make sure to fail fast. And remember, very important thing, test twice, deploy once. You don't want broken code in production. My name has been Darko Mesaros. I thank you for your time devoted to this talk. I really hope you're enjoying the reInvent so far. Feel free to follow me on the social media and YouTube and Twitch and Twitter and wherever. I do a lot more content, so if you want to see more of Bald and more about infrastructure code, make sure to check me out there. Thank you once again, and I hope you enjoyed your viewing. Bye-bye.